So the reason I want to do this is because there's a couple tricks involved. Now it's an exponential equation because you've got variables in the exponents. So for us, what we've done when we had this kind of situation is to take logs on both sides. Except which logarithm are you going to take? You can't take log base 8 on the left-hand side and log base 5 on the right-hand side. So which one are you going to use? Personally, I think there's a better choice in here. One choice is better than the other. So we're going to do log base 8 or log base 5?
Log base 8.
Log base 8? All right. That'll give you a nice simplification on the left-hand side. From my point of view, because the exponent here is a little bit messier, I think I'd rather do log base 5 on both sides because that'll clean up this expression a little bit more than having this around, you know. So let's try log base 5 on both sides. So that's going to be log base 5 of 5 to the 4x plus 2. And that's going to equal log base 5 of 8 to the x minus 3. Now the nice thing is the simplification we get here. How does the right-hand side simplify?
The 5 gets canceled out by the log.
Yeah. The exponential function and the logarithmic function cancel each other out. So what's left, Josh?
4x plus 2.
Nice. Now on the left-hand side, we're not quite as lucky. We don't get that nice, neat cancellation. In fact, the best we can do is take that exponent out front. So let me put that out in front. We've got an x minus 3 term out in front times log base 5 of 8. And there's not much we can do with that log base 5 of 8. We're just kind of stuck with it. If you look at our equation, we've got x's on both sides. So one of the things we're going to need to do is move things around so that we get x's on one side as opposed to the other side. Or as opposed to both sides, I should say. And this is one of our first little tricks. So our first trick is to distribute. We're doing this distributing so that we can move around the terms in x's. Right now you can't really move this around too easily because it's being multiplied. So let's do that. If I distribute, let's see here. That's going to mean this log base 5 of 8 terms has to multiply the x and the negative 3. So let's look at that. That's going to be x log base 5 of 8 minus 3 log base 5 of 8. Right hand side didn't change, so we're going to leave that alone. Now I do want to get the variables on one side. So, okay. For me, probably looks like the left hand side would be easier to put the variables on. So I'm going to move the variable terms to the left hand side and the constant terms on the right hand side. So let's look at that. That's going to move over there. That's going to put all my x's on one side. How about the constant terms? Do I need this term on the left-hand side if I'm trying to get all the x's over here? This term doesn't have an x in it, so I'm going to move that to the right-hand side. When something changes sides, what else changes? The signs. All right. So if you're watching this at home later, try and pause the video and see what equation you're going to get when you move this to the right hand side and this to the left hand side. Maybe you guys here can try and race me as well. So I'm going to move that to the right, this to the left. I'll get x log base 5 of 8 minus 4x equals 3 log base 5 of 8 plus 2. Okay, looking good so far. But now comes the other tricky part, the part that's going to be easy for people to forget. And that's going to be right here. I need to get the x's by itself. Right now I've got an x here and an x here. I don't want to divide everything by x because that's just going to have a divide by x over here and I'm not going to get x by itself. So what can I do to get the x's by themselves, or get one term in x? Go ahead. Yes, factor. All right, so we're going to factor out that x. So that's going to be log base 5 of 8 minus 4 times x equals 3 log base 5 of 8 plus 2. So that's the second thing. Second important step here is to factor. One more step to finish solving. What am I going to do to finish solving here?
Isolate x.
Isolate x. And how am I going to do that?
Divide by log base 5 of 8 minus 4.
Perfect. This x is being multiplied by this. To undo that, I'm going to divide both sides by that. So you're going to divide by log base 5 of 8 minus 4 on both sides. Let me just kind of skip to the happy ending. That's going to be x equals 3 log base 5 of 8 plus 2 over, let's see, log base 5 of 8 minus 4, and that's going to be our answer. Are we okay with finding the exact answer here? If all I do is ask for the answer, you're in great shape. But sometimes I might ask for a numerical approximation. Before I go over the numerical approximation, are we okay with this part? Let's take out our calculator. I'm going to show you a couple tricks in coming up with this expression, because it gets a little bit messy here. You know, I won't lie. You know, trying to do this gets a little bit messy. So we're going to start out by noticing that I have log base 5 of 8 here and here. And so I'm going to start out by just calculating log base 5 of 8 and then storing it in a variable. So one place to get to log base whatever of something would be the math menu, and then go up, log base. So I want log base 5 of 8, but don't hit the enter key yet. What I want you to do instead is hit the store key. And we're going to store that in X. So here's the keys that I pressed so far. You can kind of keep track of things that way. We're going to store that in X. So about 1.292, etc. Okay. If that's an X, then really I can rewrite this as 3x plus 2 over x minus 4. I didn't mean to write that x there. Meant to write it this way. X and then x minus 4. So really, it's going to be a little bit easier for us to input this into our calculator as long as we take log base 5 of 8 and store it in x. So that's how we're getting that expression. And that's what we're eventually going to type in. So let's do that. Now I'm going to do this in kind of a friendly way first that everyone can do. And that is, we're going to take and put parentheses around the numerator. I want 3x plus 2 divided by parentheses x minus 4. So we get negative 2.17, call it. Is everyone able to get that far? Looking good there? Now, this would be, you know, probably about an 8-point problem, so it's worth making sure you got it right, correct? So let's do one more thing. Since we're done with this log base 5 thing, let's take this answer and store it in x. So we're just going to overwrite the log base 5 of 8. So store in x. That's going to take this answer and store it in your variable x. Now the reason for that is I eventually want to be able to check my answer. So to check my answer, I want to plug it into the original problem. And here's how I'm going to check my answer. I'm going to calculate both of those sides independently. So I'll do 8 raised to the x minus 3 Should be probably a small number. Yeah, okay. And it doesn't really matter what that is. I want to compare that to 5 raised to the 4x plus 3. And I should get the same number. Uh-oh. Oh, it's because it should be 4x plus 2. All right, so let me go back there and make that a 2. I was all cocky for a second, and then, boy, I felt deflated when I saw the wrong number come up. There we go, 4x plus 2. So you're getting the same thing on both sides, so you know you got it right, which is totally cool. Comments or thoughts on this one? Looking good there? Can everyone check their answers? That might be an extra credit problem, you know, on a quiz coming up. Like, oh, show me you can check your answer. That's a good skill. So make sure you can do that one. All right. Thanks for your attention.